Hello everyone, we're going to do some examples of integration with inverse trig. And these are fairly straightforward ones. So let's look through this. So A. So first thing we notice is that's a -6, and if that's what I need this to match is I need to have that as a 1 in the numerator, right? So what I'm going to do is rewrite that integral as -6 integral 1 over square root of 1 minus x squared dx. And so I have -6 integrals of that, right? It's that -6 can be a multiplier out front, and that's usually much easier. So I should recognize that that is the derivative of sine inverse. So what's my answer? -6 sine inverse or arc sine x plus c. And that's it. I'm done. Okay, so very straightforward. You want to make your integral look like this. Okay, that's the goal. Make your integral look like that. B. So I see some things here that I can factor in B. I see an 80, I see 10 right there. So again, the goal is to get a 1 in the numerator. Okay, you always want to get a 1 in the numerator. So I'm going to factor out 80 in the numerator, and I'm going to factor out 10 as a common factor in the bottom. Integral, so that'll be 1 over x squared plus 1 dx. Well, 80 divided by 10 we know is 8, integral 1 over x squared plus 1 dx. We should recognize that as the derivative of tan inverse. Okay, usually we see it as 1 plus x squared, but it doesn't matter if it's x squared plus 1. So that's just 8 of tan inverse of x, or arctan of x, plus some constant c. Okay, so those integrals are very simple ones. I don't think you're going to see anything more complicated than that if you see anything at all. Usually integrals of inverse tan is not on the AP exam. I guess it's possible, but again, in 20-some years of exams, I don't think I've seen derivatives of tan of inverse trig, but not integrals. Okay, so that's a real quick couple set of examples there, and there's only a couple of questions in the practice on that. Good luck.